Vai ser 1, 2, 3 e já, hein?
Tá bom. Então vai, fala aí, Klaus, então.
1, 2, 3 e já. Hi there, welcome to another episode of Deep Testing, Automated Testing Beyond the Basics. We are the host Alex Freire from Nubank and myself, Klaus from Objective. We have invited today Ferreira and André Peric from Nubank and Gabriel Takeuchi from Objective to speak about end-to-end testing, testing with microservices, testing with monolith systems. Who would like to start? Gabriel, could you start presenting yourself?
Okay. Well, hello there. My name is Gabriel Takeuchi. I'm currently the DevOps coordinator at Objective Solutions. But even though my team is right now working on DevOps, we are actually developing software, and most of the time our DevOps work is actually supporting software development with testing and testing frameworks, testing tools, improving ways of testing our software and validating everything so we can deliver with quality.
Welcome. Thanks, Gabriel. Ed and André, would you like to quickly introduce yourselves as well?
So I'm a software engineer at Nubank. Currently, I'm working in the foundation tribe, which is responsible for taking care of the infrastructure and some common libraries.
And I'm Eden. I'm a backend software engineer at Nubank. I'm in the growth build, and that's the build that takes care of all the people that want to be at Nubank. We make sure that they can be safely and in a way that Bacen likes it.
Thank you all. And I guess today we want to start a little bit hearing about the end-to-end testing experiences. Like I would like to kick it off maybe saying, Gabriel, when did Objective realize that you needed end-to-end tests? We've heard a bit in our previous episode about test harness and some of that specific frameworks that you all built, but what was the story around like we really need to test these things from to try to get this breadth of experience, and where did that necessity come from?
Right. Well, I will talk a little bit about the time when I wasn't actually working at Object, but I have heard the legends, right? So once upon a time, a bunch of engineers started writing software, right, for Sky, and everything looked good at the beginning. They were working on Smalltalk and building a system that was doing fine at some point, but eventually they realized that every time, or most of the times, they tried to launch new software, things started to break apart in the production. Right? And then they realized that they really needed to have something to deliver better software, right? And then they decided, and it was they were working on Smalltalk, and they didn't have any of the cool frameworks that we have today, right? And it was just not around unit testing and any of these fancy tests we have today. Most of the companies at that time, they just didn't do it, and even those that did, there weren't a lot of frameworks, and Smalltalk had no frameworks at all, because only like 100 people in the world work in Smalltalk that day, and today even less probably. And so they decided that they had to write the whole testing software, the whole testing framework, and that arose from the necessity of delivering quality software to make sure that when they deploy it at the production, the things didn't start breaking up, right? And so in the end, the road to testing is not just a matter of delivering better software, but it's like to make yourself feel more comfortable and less fearful of delivering new stuff to the production. And I believe that's how most of the people that really started working for real, and then when they realize that they need testing, is when they get tired of breaking things up, right? And that road, from that time, we have proven that testing is extremely important, and over time, several times. And I think that the biggest testing, I think that the biggest challenge for our testing framework and for the suite of tests that we had at that time was the fact that we were able to convert a 3 million code software from Smalltalk to Java. And we converted the testing as well. And we were able to do that only because we had 14,000 tests or more, and to make sure that every time the code were translated to Java, it was still working, right? And I think that this is one of the most iconic things I have seen in my life in the software, is that is the way you can do amazing things just because you test. You can transform your code. You can keep improving, even if you don't get it right at the beginning, right? You can get improving because you don't have the fear of breaking things up, because you have the tests to make sure it's good, right?
Takeuchi, how many test scenarios did you say you had?
Well, I think that at that time when we converted the code, it was about 15,000, but today we have about 45,000 tests in that software.
Didn't that get slow? In a previous episode, Paulo Petin told us that it was like end-to-end tests, like functional tests using the database. Didn't it get slow as these scenarios, the number of scenarios grew?
Well, yes, actually, it did, because it's a lot of tests. Even though the tests itself were not that much slow, we had it was like 2 seconds test, 1.5 seconds test, and then you sum up everything with UI testing that's a little bit slower. So when you had all of these tests, yes, it gets slower, right? So today, if you take all of our suite and try to run in your computer, for example, it would take about a day or more. We actually didn't do that test, this kind of testing recently, but it's probably more than 24 hours running the whole suite. So
let's maybe hear from Eddie or André. Do you guys have similar experiences with test slowness at Nubank?
Yeah, and I think it's interesting because the history of end-to-end test, at least for me in the bank, started with us stopping doing end-to-end tests because it was pretty slow, and not only slow, it was really flaky. So what we had at the time was Nubank has a pretty strong testing culture. So had a lot of unit tests, a lot of integration tests on the service level, and we had these end-to-end tests. And we basically started an environment with real services. We use Kafka, so we had a real Kafka with brokers and using the network, and we run like some generic scenarios, not that much, and it took a couple hours to run everything, and wasn't that many tests, and it broke pretty frequently, and for us working in the growth acquisition was worse because the first test to run was ours because we need customers to do everything else, and because it was flaky, a lot of times we were interrupted to fix problems. Sorry.
Flaky tests are tests that break intermittently. Sometimes they pass, sometimes they break, right?
Yeah, and usually when they break, it's not a business rule that was broken. It's like the Kafka didn't work because we didn't want to spend too much money running these tests. And basically, it was bad because it took a lot of time, and because we were the start of the test, was a little worse for us.
So you guys were using your own test scenarios to generate data for the following scenarios.
Yes. Okay. The test itself was the data generation, and usually use that for staging as well if you want to generate a new set of data. But because of that, like it wasn't scaling, and we started to create a few tools to move out of the end-to-end test. That was contract testing and having better alerts and have quick rollbacks, so we could move out of end-to-end tests. But
what is contract testing?
Contract testing is you check it like the provider of the data against the consumer. So the provider says that he provides a name and a CPF on an endpoint, but the client say that it expects a date as well. So that's a broken contract.
About microservices. The provider and the consumer microservices. Okay.
Yeah. At least at Nubank, you could have contract testing between like mobile and backend, for example. That wouldn't be microservices, but yeah. And a lot of the bugs that we want to avoid on the end-to-end were contract testing. That's why that allow us to move out of that. And the alerts were not to avoid problems, but avoid bugs to become big problems. You see faster, that is a problem, and roll back. But we still have a necessity of the end-to-end test for two reasons. One is the confidence that Gabriel said, like you can understand the whole domain that you are looking just for one service in a microservice scenario. You can understand a lot of it, and it should be segregated, but there's a bigger picture that you want.
How many microservices at Nubank, just as a curiosity?
I don't make perhaps André can help me, but I think more than 400 now. But at the time that I'm talking, I think 100, more or less. Like it grew a lot from there, and our team itself was like 10, a little more. Don't remember correctly, but yeah. So was understanding, and another thing was exploration. Sometimes you just want to throw things there to see what happens, and of course you can do that in production, and having that like be fast, you do more, and then you have like more confidence, and you'll be able to explore things more risky. Yeah.
But we see this need of having some sort of end-to-end testing, right? And then two different strategies when we start to feel the pain. The basic pain is, oh wow, it's slow. Right. The other pain that we had at Nubank because of our microservice architecture is like your commits would get on a queue, but if anything broke on the acquisition test is the first one to run, all the other commits in the queue would have to wait another hour or so until we fix that. And at one point, I have the data here. We did an analysis. Out of 1,000 runs of our end-to-end testing and staging, 42 failures. Only one was a bug. The other 41 were either flaky tests or like network timeouts, or somebody did that exploratory testing manually in the same environment and broke the data, and that was an unsuspected side effect. And then I guess I would love to hear from Eden and André. It's like the strategies. Like we talked a little bit about contract testing framework, but we also had another development that's really interesting in terms of being able to get that same safety without the slowness. But how did Objective tackle this slowness pain? I mean, you're not waiting 24 hours today to run this suite every day, right?
Yes.
Right. Yeah. So how did we tackle with that problem, right? So what we did, so we decided that, okay, at first what we did, so we had a nightly build, a nightly run of tests that we started like 7 p.m. or 8 p.m. And then we had someone hired in the company. He was called the builder. And so the builder was like a trainee, or even someone that actually didn't had any expertise in programming or anything like that. We just hired someone to go there and push a button. And he said, so let's run the test. And he pushed that button. And then he went to do whatever he wanted to. It was like reading magazines and playing stuff. And the only thing that he had to do, right, was to check where their things were still running. And we had like 6 or 7 servers to run that. But even then, that took.
He would restart the servers if they failed. Is that it?
Yeah. So he was responsible for checking whether things were breaking up, and we even had a funny when we had a funny alarm that when at some point we created a way to monitor the tests, and it was a screen that had the tests that were running, and if some tests failed, there was a school, like a deaf school, showing up and throwing an evil letter. So it would draw the attention of the builder, so he could go there and notice that, oh, it stopped, so let's do something. And then he went there and tried to restart, and if it didn't restart, there was a development team that was responsible for taking calls for him and to help him.
What year was this, more or less?
It was 2008.
2008. Okay.
2008, 2009. I think that reality actually stood up for until 2010 almost. But then we were also working. We were already working with Jenkins. Actually, it was Hudson at that time. Then it became Jenkins, the continuous integration server. I think that most people here know. And we were working on automating everything and to run that unattended, and that in a way that it didn't depend of a person going there and push a button, right? And we were at the point that at some point we decided that we want to run that faster and make it possible for a developer to run the test by himself in a timely manner, in a feasible time, right? At least 2 or 3 hours at most, right? That he shouldn't wait for the whole day. Then what we did at first, we built a cluster with the old machines that people just discarded, right? The developers were recycling their stuff, their computers, and the junk, let's say. We used those junk to build our cluster, our Flux cluster, okay? And then with 20-something machines, we had the first cluster to run our tests and provide the testing as a service, let's say. So we had, we call it harness as a service, right? Because of our framework. And then the developers were able to go there and start a job, a Jenkins job, that would run the test on his branch, right? And it was pretty good. We had some, it was very nice because the test that took about like 12 hours to run, it would take about 2 hours and a half or something like that. It was quite an evolution, right? And we had an issue because we had a lot of developers, and a lot of the developers wanted to test. They wanted to run the whole suite, and just like
How many developers sharing the same test cluster at the maximum?
Yeah, at that time we had I don't know, like 40 or 50 developers working on NG. All of them wanted to run tests, and it was pretty. So even though the tests were fast, you were not able to run your tests, right? Yeah, either you were lucky to get a place in the queue to test it until before the end of the day, right? Or you just let it queued up to the next day, and even worse, we had a lot of issues with flakiness as well, but not just flakiness of tests, but the flakiness of the whole setup, because we run the tests as an attendant, and sometimes the whole suite just froze up, and it was a random thing. But eventually we found that it was an issue with the specific OS that we had, and we worked a lot to improve. And well, at some point we had we started to hear a lot about AWS, right? And we wanted to take that to the next level, and we had a dream, like it was like oh, how good it would be if we had AWS to run all of the tests in like less than 1 hour, and everyone would be able to do that, to have this service. And it would be we would eliminate a lot of issues that we have today because of this low test, not just because people were not able to test, but because things went untested to the main branch. We had to do reports every day, and the reports had the issues, the tests that were breaking up, and then we had one of the directors, the main directors of the company. He had to go through the report and then go to the subversion history to find who would be the person responsible for that scenario. So it was crazy. Like one of the most expensive person in our whole company was doing that work like 2 or 3 hours per day. And so we finally got the green light to go to AWS, and then we worked to take the whole testing as a service to a new level. And today what we have is that any developer can go there and just say, I want to test my branch. And then it will set up everything that he needed to run the test, right? And it will spin up like 45 instance or whatever you need to run the test under an hour. And you can have multiple test suites running at the same time. And all of these would be running like an hour 10 minutes, which is okay. I will say it's not perfect because I would like it to run in like a second, right? But it's pretty good, taking in consideration that after an hour or so, you get to run 4,000 or 5,000 end-to-end tests that it's connected to the database. It run UI tests. It run unit tests. It tests installation on the database. It tests a whole bunch of things, right? And you get all of that just for an hour. So it's been it was pretty good, and it makes, so with that we are able to do what we call the master branch. We have the golden trunk, and that means that the main branch doesn't have broken tests most of the time, at least, unless for the flake tests that we still have it, but we don't have a lot of those today because we actually fixed most of them. And when you have your main branch like that, it's like it's a deliverable, right? You have the continuous delivery, because even though you don't have the artifacts, you know that the code in the main branch is good, and you can take that, right, generate the artifacts, and it's good to go.
Very nice. Do you know how much it costs for a single spin of these, 40 machines times 1 hour, does it cost like $1, $10, 10 cents? Any idea?
Right. So we do use one of the things that we made sure was to use the AWS bidding service that they call the spot market. Right. So the spot market, you can ask for a machine and you do a bid, like you say, I want to pay like 10 cents per hour, and if your bid goes through, then you can have that machine for 10 cents, right? So I'd say, let's say, okay, 10. Let's round to 10 cents. It's around that for
per
it's
machine.
around that per machine. So
okay,
we have like $4 per run.
Okay.
Like $4.5 per run.
Very nice.
Yeah, and I wanted to go back to Nubank's side of the story, right? So, okay, for different reasons, it's like it's slow, it's flaky. We decided to end end-to-end testing in the staging environment, right? A lot of that was fixed with the contract tests, so that the things that we would find, hey, why did you change your API and not tell me? That would break in staging, but now it breaks earlier in a way that we get a lot of that safety. But what was missing, Ed and Andres, you missed something, right? You had the service level integration tests, you had the functional tests, like micro tests for our business logic, you had that contract testing, but what were you needing so that you actually went and developed a way to do multi-service end-to-end testing there? Maybe we can hear from André before, and then Eden can complement.
Yeah, so contract testing is a great tool for detecting breaking changes across services. So like if a service A changes some endpoint API, service B won't be affected. But we realized that we need to test behavior across many services, and that testing only the contract is not enough. So maybe a nice analogy is that imagine that you have a program in a statically typed language and it compiles, but so the types are satisfied, but this does not imply that the program is correct, of course. And so we should not assume the same thing for microservices. It's not only because the contracts are correct that the final behavior and like the final interaction between many services actually makes sense. So end-to-end testing, like we think it's necessary. On the other hand, the most common implementation of this kind of test is having a separate environment. And we realized that this doesn't scale. And so it worked fine when Nubank had only a few services. But as Nubank grew, like the time that the entire switch took to complete, basically it would grow exponentially, not nearly, by the way. So we changed our strategy for end-to-end tests, and we experimented creating a project that would require all the services you want to test. So this runs in a single JVM. Imagine that it's a single project that you require all the services you want to test as if they were libraries. So you require everything, and maybe this won't probably cover all interactions between those services. So you may need to mock, and you may need to stub some interactions. But this worked fairly well because we use Clojure at Nubank, and we can start a REPL in this project that includes all the microservices you want to test, and you can basically run and test interactions across many services, and you can change stuff interactively. So let's say you are testing some flow and there's a bug, and you can fix the bug in a specific microservice, and you will see the result instantly. So this worked fairly well.
André, you mentioned, so it's multiple microservices running on the same JVM, is that it?
Yeah, that's right. We call this multi-service testing.
Multi-service testing. But how didn't you guys use Kafka and stuff like that? What you do with the calls between the services and Kafka, the brokers?
Yes, so each microservice has a set of components, right? So each has an HTTP component, a Kafka component, a Datomic component, which is the database that Nubank uses. And there's a set of components for production, and there's a set of components for tests. So let's say you are developing in a single service. When you write a test for this service, you will use the test components, right? So the way that the multi-service tests wire multiple services is by starting all the components of each service, and each knows how to redirect HTTP and Kafka messages from one service to another one.
In the same JVM.
In the same JVM, yeah. So for example, if some service produces a Kafka message, it will go to a queue, which is just like an atom enclosure. So it's totally local. It doesn't require any external interaction. It doesn't require network connection or anything. And the framework knows how to tell the consumers that this message has to be consumed.
So it's absurdly faster than using.
Yeah,
Kafka,
it's way faster.
Same machine.
Yeah. Like if you can run a test in a few seconds, if it's slow.
Mm-hmm.
And so at this time you were working on like some of the credit card rewrites that we were doing, that any single operation requires coordination between multiple services, messages that go and come back, and I guess that level of complexity, as you said, contracts aren't enough, and you kind of, the team invented this way of having something end-to-end that doesn't rely on a staging environment that can run locally, right? And I guess we like to let 1,000 flowers bloom and then standardize when it makes sense. At around the same time, growth had a similar challenge, right, Eden? And you came up with something very similar. Can you tell us the story on your team there?
Sure. So yeah, we had a similar necessity, but particularly we were interested in how we can describe tests in the user view, like how a customer client sees our system, and then run this, because we get tests and documentation at the same time. But the implementation, the technical part, was really similar, because it was like a good decision, the microservice architecture that we have in the bank that allow us to do that. And our solution, and like we talk about it, we saw each other's solution, they are pretty similar, but with one difference, that is it can be a big difference depending what you want. The what Peric was talking about, his solution uses a local queue that simulates Kafka. It's fast, but it's still a queue. In our solution, we decided to go deterministic all the way. So it's not a queue. When we produce a message, we call the consumer. And if it produces a message, it calls another consumer. If it is 5 services deep, we do that. And it's a depth first search in a graph, basically. And something that it happens, and it's kind of funny to have this kind of problem. We had some problems of stack traces that were too big, because were 5 services worth of stack traces, and were big at a point of breaking the editor because he didn't know how to, it froze for a few seconds and then he gave up to printing the whole stack trace. But yeah, that was the idea. And something that we also did right at the beginning was to decide that the way that the tests were to be written, like when you look at it, were to be high level. We hope that anyone at Nubank that understands the domain would be able to read those tests. And that's not only good for other people to read, but for us engineers to keep thinking of what matters, right? Is what it will do to the user. But yeah, but the solutions in the end were pretty similar because of the architecture of the microservice. It was natural, and what that also allows that is pretty good is that we did that without changing any code in the logic of the service. We had that logic and we wrote an infrastructure that you can plug those services there and test if the codes already work. You don't have to go there and change the logic. And that's both the one in growth and the Peric on the credit card also do that. So that allows us to not think about it. We don't have to think about any integration test when we read in code. We read as always, and then we run the integration test, because it's as great as it is, you don't want to run every time you change a line of code, right? So you want to have a big change and then see if it works. You could if you wanted, but every line, but I usually don't do that. But yeah.
I'm curious to see what these tests look like. If you could show the DSL maybe in a moment. Maybe Gabriel could show us some reporting you have, some stats you have on these runs, on these builds that you guys had, and then André could show us what the tests look like in your framework, and Edin could show us what these tests look like from the point of view of a user.
Okay, yeah. Just before I start showing the reports or anything like that, I was curious to ask the Nubank people, André, Eden, Alex, about these tests you are running. Where do you run these tests? How many runs do you have usually? Do you run in a server, an integration server, or are these tests run on the developer machine?
Yeah. So when you are developing, let's say when you are on a local branch in a microservice repository, you can run all the tests locally, right? So it's important to say that we have multiple mode service tests repositories. So there's one for the credit card team, there's another one for the billing team. So you don't want to run all of them in your machine, but only the one related to the microservice you are changing. So you can do that, and it's integrated in the CI as well. So when you open PR, the test is run. So we are experimenting this integration, and we are like evaluating if it makes sense, because not everyone agrees that this kind of this kind of tests should be used as a regression tests, because like they are useful when they are most like they are really great when you are building new stuff. On the other hand, when you are just improving some very local thing, they are less useful. And this switch does take a while to run, like it takes 15 minutes or so, which is not too much, but like compared to the other steps, which like it's long. And sometimes I guess it's the longest CI step.
Yeah, at Nubank we have a pretty low bar from commit to production. Usually it's half an hour between merging a pull request and going to production. So 15 minutes is a lot. But one thing that I would add is like, because it's closure and we are running a REPL, you can change the code of the service live, load the namespace and run again to see what's happened. And that can make also like the experience pretty fast, not only that the test run fast. Because I was thinking as Peric André was saying, because we already use that for debugging bugs in production, because we just reproduce the error on the integration, and then we can like put print whatever we want. I like to debug with print, so I use that, and it just run the test. And you can like zoom in on where you want pretty fast. And if we depend on running staging, like importing data or something like that, would be pretty hard. And Clojure itself, the REPL itself, allows us to do that pretty easy, because it's just code. Like, it's not any different than using the REPL for unit tests, for example.
And then, do you see that like the use case on your side has mostly been around driving new development? So you write the acceptance test, it's a scenario, it's like behavior-driven development, right? This is the behavior that I want to build. Let me specify it so that the test is actually part of the requirement then, right? We're understanding what we want to build. Or do you also use it for regression?
We use for regression, but the regression is kind of orthogonal. It's more that we want to document what we have, and the test is a way to make that to be easy to be up to date. But so it's not the regression that we want, and that's important because what we do a lot at Nubank and the growth BU is testing A/B tests, or when we have a new feature we want to do rollout. So we will change just a part of the process. So having the status quo there also helps a lot, because in the end we will copy paste a lot of stuff. So having like a stable default helps with that. But we don't try to get corner cases or anything like that on the integration tests. Is not that many tests. Usually tests that is the longer possible process instead of the shortest one. But it's more focused on the documentation, the tests, the status quo tests, instead of the regression itself.
So regression is like a side effect, like a side product of the way you test.
Yeah. Okay. Like we are testing the regression of the documentation, not the logic of the system in a way.
Okay.
And Gabriel, on objective side, what is the primary use case? Is it like driving new development, or is it regression, a mix of both?
Well, most of the tests we do is for regression, right? We do have some case of working on test-driven development too, but unfortunately, that's not the commonplace. yet, especially for tests that are too complex. They end up just writing for regression, right? But it is an unnecessary part of the process. Anyway, every time the people create a new feature, it's mandatory to create the test to make sure that the feature works, right? And so that's the way we do with most of the tests. But we do have unit tests as well, too, right? And so that's where people try to do a more test-driven approach. But even though we do have unit tests as well, it's compared to the amount of integration tests that we have, it's not that many. We do have like, I don't know, just today, I think it's just 3,000 or something like that. Not too many for the amount of code we have, right? But so the integration tests are the ones that are the main focus of the test development in our company, at least for this product, right? We do have other have other squads. Most of the squads work on different kinds of software, and then I'm not sure which approach the other squads are using. Okay, so I do know a few of those, but not all of those.